Hi guys! Salamat sa inyong patuloy na pagsubaybay dito sa ating ginagawang discussion about statics of rigid bodies. In today's discussion, we shall be solving problem that will deal most of the application of the concept in equilibrium. Guys, tingnan natin itong ating problem. Determine a general expression for the normal force NA exerted by the smooth vertical wall on the uniform slender mass of M and length L. The mass of the cylinder is M sub 1 and all the bearings are ideal. Determine the value of M sub 1, which makes letter A N sub A equals mg over 2 and letter B N sub A equals 0. So guys, ang problem nito ay mas nangangailangan ng application ng concept. Kaya minabuti ko na ito yung ipakita natin sa ating discussion ngayon, sapagkat kapag naintindihan natin ang application ng concept, mas madali nating masosolve ang problem. Kaya balikan natin guys yung mga basic concept to consider in dealing with this kind of problem. Una, dapat alam natin ilang bodies ba ang involved in the problem at paano sila nagkaroon ng interaction with one another. So bakit kinakailangan nating maintindihan itong part na ito? How do they interact with one another? Dito kasi maintindihan natin kung paano nag-exert ng force ang isang body upon the other. And that is very important when we draw the free body diagram. Kaya nga isa sa ating i-review ngayon yung konsepto ng free body diagram. In this review, sometimes we ask ourselves, alin ba yung dapat kong unahing i-drawing at bakit? Normally, we start with a body that where unknowns can be solved using the conditions of equilibrium. Pinipili natin yung body na kung saan masosolve agad natin yung unknown sa pamamagitan ng pag-apply ng condition of equilibrium. At dahil sa pamamagitan din niya, nadidetermine natin ang magnitude at direction ng force that are acting upon the body. What else? We will also be dealing here with the resolution of force into components. Balikan lang natin to guys, itong resolution of force into components. Kasi napansin ko, kapag tayo ay nagre-resolve ng force into components, ang kalimitan kong nakikitang ginagawa ay inire-resolve natin siya into horizontal and vertical components. Actually, tama yun eh. Pero bakit ganun ang ating kalimitang ginagamit? Kasi nga, yun ang ating convention. Doon tayo nasanay. At sa tingin natin, dahil nasanay nga tayo doon, yun ang mas madali para sa atin. Pero alam nyo ba, in most cases, forces are resolved into components that are horizontal and vertical, di ba? Pero sometimes it is also useful to consider other directions. And when we do it, the solutions become simpler. Kaya sa konseptong ito, gamitan natin ng resolution of forces, not necessarily the horizontal and vertical axes, but we shall be using certain axes that will make our solution simpler. And lastly, hindi natin dapat makalimutan yung application of the conditions of equilibrium. Ano-ano nga siya? Siya yung summation of force vertical, summation of force horizontal equal to 0, at summation of moment about any axis equal to 0. Kaya simulan natin itong solving guys. So let's start with determining the tension on the cables that are used to lift or to support the mass M1. Kung mapapansin natin, there is a cable BC, CD, DE that is running over a frictionless pulley. Bakit ko nasabing frictionless? Kasi nabanggit sa problem, the bearings are ideal. When we say bearings are ideal, ang ibig sabihin nun, they are made so that friction is almost negligible. Sa makatwid, we can assume here that the pulleys are frictionless. Sa mga katwid, if we shall be isolating pulley E as an FBD, from here, we can solve for the tension on the cable DE. And that is, okay, drawing here, if we shall be having that hour as FBD, then at point E, there is a weight that is acting due to the mass of the cylinder. And if that weight will be substituted with this value, it will be equal to the product of m sub 1 times the gravitational pull at gravitational attraction of the Earth. Now, on this pulley, there runs a cable. Sa mga katwid, kung ipapakita natin yung cable, then the cable will be subjected to tensions. On the left, dahil hindi natin alam ito, so we can simply label it with T sub 1. While on the right, it is a cable that acts on this point DE, so we may simply write it as tension on DE. So, if we will be solving for this tension, T sub 1 and T sub DE, we can find that the two shall be equal. And how are we going to prove that? If we shall take up moment about E, then that equation will yield to an equation that T sub 1 is equal to T of DE, because the two will be causing a moment about E in the opposite direction, and whose moment arm shall be the same. Hence, the moment arm will cancel, and that T sub 1 will become equal to T sub 2. And that is our equation. Now, if we will be summing up forces vertical, this equation will give us a value of T sub 1 and T sub DE, and that their magnitude shall be equal to 1/2 of the weight, or simply equal to 1/2 of M1 G M1 multiplied by G. Now, afterwards, what shall we do? We can now isolate pulley D, this pulley. And when we isolate pulley D, we can compute for the magnitude of the tension on this cable CD. So that when we isolate pulley D, we can solve for the tension at the cable CD. Now let us try to isolate that part. It is our pulley D. Now at point D, there is a force or reaction acting at that pulley. And let us call that as D sub V. And we also have a horizontal component of the pin acting at D, and we will be calling it as D sub H. Now we have removed here the cable, therefore we can represent the cable by the respective magnitude. So we shall have here T of DE, and the other side we shall have T of CD. We have known T of DE, and that is equal to 1/2 of mg. So that if we will be summing up moment about D, then we will be getting the magnitude of T of CD, which is equal to T of DE, and that is also equal to M1 over 2 multiplied by G. The same way is true when we isolate pulley C. If this pulley C will be isolated, we shall be getting the tension at the cable BC, and that when we do it, here is our pulley C. If we shall be defining the force acting at the pin that is removed at the center of the pulley, which is at C, therefore we shall have here C at the vertical component and the horizontal component of the pin reaction at C. Now we have here removed the cable, and therefore we will be showing the cable. The cable shall be subjected to tensions such that you should have here T of CD, and the other one is T of BC. And again, we will be taking up moment about C, then we shall be getting that T of BC will be equal to T of CD, and that is also equal to 1/2 of M sub 1 multiplied by G. Afterwards, what shall we do? So if we will now be isolating the bar as free body diagram. This bar, we will be isolating this part. Let us do it. Hence, we try to isolate that part, and on that bar, we try to indicate all the forces acting. Now, at this point, B, there is actually a cable that runs. So let us imagine the position of that point B. It is acting at L over 3 from the top, or 2/3 L from the bottom. And at this point, there is a tension, represented by the magnitude M1G. And this tension is making a total angle of 60 degrees. Therefore, that angle is equal to 60 degrees. Aside from that, we have the weight of the cable. According to the problem, the cable is uniform. The bar is uniform. Therefore, the weight must be acting at its geometric center at this point, whose distance shall be equal to L over 2 from the bottom or L over 2 from the top. And there is this weight equal to the product of the mass multiplied by G, where M is the mass of the bar. At this point, okay, we have also the reaction exerted by the wall, and that is what we mean by N sub A. And this is what we will be looking. We will be expressing the general expression of N sub A, considering that these are subject to these forces, okay, on the body. Then, aside from that, we shall have here, okay, the pin connection at O. So we have here O sub V and O sub H. Now, let us now try to identify the moment arm. Now, let us consider that this, okay, if we will be resolving this force exerted by the cable CD into components, this is what I mean, okay, resolving the components, not necessarily the horizontal and vertical, but rather, if this cable, or if the tension in this cable will be resolved along the direction perpendicular to the bar and parallel to the bar, then we shall have this one. You might be asking why it should be resolved this way, because it is easier to define the moment arm of this component, because it is given already the magnitude equal to 2/3 of L, and that the component that is parallel to the bar will have no moment about this point, diba? Because it will just pass through this point. Okay, and the magnitude of this component that is perpendicular to the bar, this being 60 degrees, shall be the opposite side of this angle 60, and it's equal to M1G over 2 multiplied by 60. Whereas this component that is parallel to the cable or to the bar will be equal to M1G over 2 multiplied by cosine of 60. And because the bar is inclined at 30 degrees, therefore, the moment arm of this weight of the bar will be equal to L over 2 times cosine of 30. Similarly, this N sub 1 being horizontal, because the wall is vertical, will have a moment arm equal to this distance, equal to that distance. And this distance is equal to L multiplied by sine of 30. Now, after we have known and identified the moment arms as well as the magnitude of the force acting on the bar, then we can now make an equation that involves our NA, the weight of the bar, and the tension acting on this cable CD by taking moment about this point O. So that when we sum up moment about O, which is equal to 0 because that is in equilibrium, then treating that counterclockwise as positive, then we shall have the equation such that M sub G representing this magnitude, and whose moment arm is equal to L over 2 times cosine of 30. Okay? Whereas this N sub A will be clockwise, therefore that would be having a negative moment multiplied by the moment arm, which is equal to L sine of 30. That is multiplied by L sine of 30. Okay? The moment due to this one will also be negative, and that is equal to M1G multiplied or divided by 2 multiplied by sine of 60 multiplied by the moment arm, which is equal to 2/3 of L. That is 2/3 of L shall be equal to 0. Now you will notice that we shall have here an equation that involves the cosine of 30 and the sine of 60. Because 30 and 60 are a spatial angle, you do not have to use your calculator to obtain the magnitude of the cosine of 630 and sine of 30 or cosine of 60, because they are spatial angle. What we can do is to also derive this relationship or this magnitude by the use of spatial triangle. And how do we do it? Now let us imagine that somewhere here we have an isosceles triangle, an equilateral triangle. Equilateral triangle such that their sides are equal to 2. If their sides are equal to 2, therefore the angles of an equilateral triangle are all equal to 60 degrees. They are all equal to 60 degrees. Now let us imagine that we bisect this side, or we pass a perpendicular line that passes through this point, so that you have here a dividing line, so that These two will now be divided into 1 on both ends, and the 60 will be divided into 30 on both angle. Now, if we will be considering one side of that triangle, and we consider this side, so how do we call this triangle? We have seen here, okay, a special triangle, a 30, 60, and 90 degree triangle, where this side can be taken using Pythagorean theorem, that is equal to the square root of 4 square minus 1 square will be equal to the square root of 3, and that gives us, okay, the magnitude of the side of the side of the triangle. And now, knowing the triangle, having the three sides known, we can define the functions of the sine and the cosine of the angle, so that, okay, the sine of 30, which is also the same as the cosine of 60, will be equal to 1/2. Whereas, okay, the sine of 60, the opposite side of this angle, which is the square root of 3 over 2, is also equal to the cosine of 30, and that is equal to the square root of 3 over 2. Now, after we have taken this, we can now substitute these two values here in the given, or in our equation, so that substituting the value, we have mg multiplied by L over 2, the cosine of 30 is equal to the square root of 3 over 2, so that is equal to the square root of 3 over 2. If sine of 30 will be substituted by 1/2, therefore this equation becomes minus NA times L over 2, because L times 1/2 is L over 2, that is L over 2, minus m1g over 2 sine of 60, and sine of 60 is also equal to the square root of 3 over 2, that is the square root of 3 over 2 multiplied by the moment arm of 2L over 3, and that must be equal to 0. Now, you will be looking at the equation, you will notice that L will cancel each other. Similarly, these twos will also cancel, and the denominator 2 can also cancel each other. So that when we simplify the equation, what will happen is that, and then we solve for NA, we transpose this NA to the right hand side of the equation, and then we arrange, and then that becomes NA equal to, ang matira na lang dito is mg, the square root of 3 over 2. Whereas here, ang matitira na lamang dito is m1g times the square root of 3 over 3. Now, if this equation will be multiplied by the square root of 3, if we will be multiplying, I'm sorry, this is already the equation. This is already the equation of the general expression of the reaction exerted by the wall at A, which is equal to, okay, NA equal to mg, the square root of 3 over 2, minus m1g, the square root of 3 over 3. And that is our, okay, answer for the general expression of the reaction at the wall. Now, in order for us to solve for, okay, letter A here, sabi dyan, what is the value of m sub 1, so that n sub A will be equal to mg over 2, so that we shall be, okay, substituting, so that sabi dyan, if NA shall be equal to mg over 2, then we substitute that value, therefore mg over 2 will be equal to mg, the square root of 3 over 2, minus m1g, the square root of 3 over 2. So in this case, okay, we can now rearrange that so that we can have m1g, the square root of 3 over 3 shall be equal to mg, the square root of 3 over 2, minus mg over 2. Now you will notice that g will cancel each other, ba? And that, what will happen now? So if we will multiply both sides by the square root of 3, so what will happen on the left? This becomes m1 times the square root of 3 times the square root of 3 over 3 shall be equal to m3, m the square root of 3 multiplied by the square root of 3 over 2, minus m the square root of 3 over 2. Now you will notice that this, the square root of 3 multiplied by the square root of 3 divided by 3 will just cancel each other. What will remain is m sub 1. Whereas this one will be what? This becomes m times 3 over the square root of 2. Ba? And then simplifying, so you have the value of m sub 1 equal to m over 2 times 3 minus the square root of 3. Now for the second question, so that what will be the value of f sub 1 so that NA will be 0. So going back to the general expression of n sub a, so that when n sub a will be 0, we substitute this value to be equal to 0. That becomes now k equal to mg the square root of 3 over 2 minus m1g the square root of 3 over 3. When we simplify, so this becomes now equal to, okay, g there will cancel, but as well as the square root of 3. So what happens now is m1 will be equal to 3m over 2, or simply 3 halves of m. And that becomes the value of m sub 1 expressed in terms of m, okay, when the reaction at the wall is equal to 0. Okay, guys, I hope that you are able to follow the solution that I have presented to you. That is, with the use of the basic concept, even without using calculator, you can solve a problem. Lalo na kapag nasamahan pa tayong concept plus your understanding or your knowledge about how to use properly your calculator, then that could be best. One thing is sure, you can solve the problem. Again, thank you guys for watching.